All right. So, hey everyone, welcome to our group's presentation on handling exceptions and errors. And we're going to tell you a little bit about how you can handle errors in Python using Python. And my name is Srikar-InformationsSysMgmt, and we have David Dickens and Karthik Arthuri. So, what are exceptions? So exceptions are type of events that occur during the execution of program and that disrupts the normal flow of instructions. So where, if you have programs, there are some errors that occur all the time, and there are some examples, kind of like zero division errors, file not found errors, types of errors, and value errors. Some common, you know, these errors happen when there's quality data sets or some data sets that you are unfamiliar with, and you want to be able to accept these errors. And so we're going to talk more about that. And here you go. Karthik?
This is just a very simple example of the syntax of the try except block. Um, so this is a way for, as he said, us to test various code for an error and then deal with the resulting code. Here's a very simple example, as I said, where we try a function that's obviously going to return a divide by zero error here. You can see we try it up here. Then our code checks for any exceptions in this case, not just the divide by zero error. And if so, prints error. So multiple types of exceptions can be checked with this clause. Here we have three examples of how to check specifically for a file not found error, for a divide by zero error, and for catching all other exceptions as stated below.
Additionally, we can use some finally blocks or else clauses to assist in our exception handling. The finally block is always executed regardless of whether or not an exception occurs. So this is good to know if you're not sure whether or not a process has finished running. You can have a finally block, send some type of message to let you know that we've gone through, like we've mentioned before, maybe some try blocks and we've completed that process. Also, we could use, oh, if we can go back, we can also use the else clause. This in a try block, this is useful if no exceptions occur. So this is usually helpful to communicate a successful execution of a block of code and that we didn't need to handle any exceptions in a block. When it comes to implementing exception handling, it's really about striking a balance between the time you spend to write the exception handling versus what exceptions you anticipate encountering with the code. We kind of mentioned earlier that if you have a specific data set that you're starting to work with, if you know that there's a chance that there will be divide by zero errors or something along those lines, you want to spend the time writing some exception handling to handle those, and maybe not as much time for file not found errors, as an example. You want to write your exception handling to handle some specific exceptions rather than all of them. This just helps inform whoever's using the code to know what went wrong and where we need to maybe examine the data. Again, using meaningful error messages along the same lines helps someone find what went wrong and how to improve the code. With all of this, testing is going to be key as you're getting into a new data set or using new code. You need to understand where things are failing, how improvements can be implemented before you have a um, code that is really useful and ready to be deployed.
So in conclusion, so we wanted to say that exceptions disrupt workflow and code, that try and except block is used to handle exception in Python, and then the finally block and else clause add control to the error handling, and code with exception handling is more robust and reusable. Um, so this is our presentation on handling errors. Thank you.